Okay, hello everyone. Thanks for joining us. This is the introductory telecon for the Midwest Space Grant Midwest Power Rocketry competition for 2022-2023. We will repeat this telecon or this content in January for teams that are not forming right away, but I'm glad you're here and you don't have to wait till January to get started on things. I'm James Flatten. I work for the Minnesota Space Grant. I'm located at the University of Minnesota Twin Cities. And I thought I would do the following, just looking down the list of who's on the line. Just run through the list one at a time and have each person just say a note about themselves, including for everybody, where they're from, and maybe what background they have in rocketry. That would be a start. I'm going to start with Gary.
All right. My name is Gary Stroik. I'm the technical advisor for the competition this year. And so my background is based in high power rocketry for about 25 years now. I'm a level 3 flyer and have been involved in this competition for years or so, initially as a judge or a mentor for some teams, and then a judge, and then co-organizer since I think about 2014 or so. And that's I guess I'll just leave it at that. So
Okay, thanks, Gary. You were breaking up a little bit. Hopefully that's
sorry
on your end, not on my end, but let's just press on. I'm going to say hi to Frank.
Hey, good evening, everyone. Some of you may know me, Frank Noble. I organize with other people down here for Wisconsin Space Grant competitions for the FNL and the CRL, and I've been working with the Minnesota group for probably, I don't know, maybe from its existence. I'm not sure, but it's been a long time. But it's a lot of fun. I like working with them, and a nice launch field.
Thanks so much, Frank. Welcome. It turns out that once we get started on the slides, I'll do most of the talking, mostly because I wrote the slides and Gary hasn't even had the chance to react to them very much yet. But he and anyone can give me feedback on them. They're brand new, really they are. Abigail Carlson, where are you from? I'd like you to add your school name to your name, but tell me where you're from. Are you there, Abigail?
Yeah, sorry, I'm kind of doing two meetings right now at the moment. I'm from North Dakota, West Fargo, the eastern side of the state, and I'm a second-year physics student. That's
were you involved in the North Dakota team? Were you involved in the North Dakota team last year?
No.
Okay. Well, and which school in North Dakota again?
Oh, I go to Hamlin University in the cities.
Oh, I see. You're actually from Hamlin, but you're just saying you're from North Dakota.
Yeah, sorry.
No problem. No problem. I'm most interested in what school you're representing here. So that's great. Thank you. Andy, Northwestern. Andy, are you there?
Hi there. Yeah, can you guys hear me?
Yep.
Awesome. Yeah, I'm a second-year aerospace engineering student at Northwestern. I was involved with the team from NU Stars last year, so we were up in Minnesota with the NSG competition, and I'm looking forward to getting started this year.
Super. Welcome, Art.
Art Gibbons. I am in my 50th year of flying rockets. Yeah, I'm old. Level 2 flyer. I am the mentor for the Bethel team, past president of the National Association of Rocketry, Minnesota, section 576 MASA. So that's my rocket experience.
Excellent. Welcome. And Ben, also from Bethel.
Yep, I'm Ben from Bethel. I joined the Bethel rocket team last year, so I competed with them last year, and I've been flying for a year now.
Super. Let's see, Caden. I'm surprised to see you, Caden. I'm glad to see you.
I join and see what's going on. I have not been around for as long as Gary, Arts, or Frank, but some of you may recognize me from last year. I was a judge last year. I'm level 3 certified, looking to be a judge this year, hopefully, or mentor some teams. And I fly out of Tripoli, Minnesota as well with Gary. So.
And you have graduated from here. So where are you now?
I am at Uni Systems Engineering in Plymouth, Minnesota. So just mechanical engineering.
Super, good to see you again. Who's on the line from McAllister? I see possibly 2 people.
Yeah, hi, I'm Chloe. I'm a senior physics student at McAllister. I was in last year's Midwest High Power Rocketry competition, and I launched with our team 3 rockets, and then I was also in like a group build and also tried to build a certification rocket by myself in the last 3 years. Yeah, that's kind of my background. And I'm a second year physics major, and I was part of a group build last year. I kind of helped with the competition last year, but I wasn't able to like show up to it. And then I have a certification build that will be launching this fall. So
super, welcome. Fatima.
Hello everyone, my name is Fatima Mohammed. I am a sophomore physics major at Hamlin. I was involved with the Hamlin Club last year, and thankfully I got my level 1 certification last year at the Midwest competition. And everyone, I'm also excited to be competing this year.
Excellent. Also from Hamlin, Kevin, say hi.
Hi, I'm Kevin Stanley. I teach at Hamlin. Our school tried this for the first time last year. We're trying it again, and I want to be involved.
Very good. Welcome back. Steve.
Yeah, I'm Steve Hyland from Fond du Lac Tribal and Community College up in Cloquet. I'm the advisor for the Thunder Rocketry Club. So I've got some students who sound interested in attempting this, but it sounds pretty challenging, so we'll see. But might get something going.
Super. Good luck to you, Sydney.
My name is Sydney. I'm a senior applied physics major at Hamlin. I got my level 1 certification last year, which is the first time our school did it.
Okay, welcome. Good to see you again. Anybody I missed? Okay, I'm just keeping notes to myself about who was here. And again, I will post this recording so that you can share it with other people. But let's do the following. Let's go immediately to the competition website. So this competition website, hopefully you're familiar with the fact that this exists. I just put a couple things up here just now, and I'm going to click on them right now. They are slides for this introductory telecon, and also a competition handbook, which I will concede is missing 1 page. I have drafted the page. I just haven't convinced myself that it's ready for posting, but I probably will right after this is over. So this will become V1 very soon. Let me click on the introductory telecon slides and let's just talk through these. So we have circulated, and hopefully most of you have seen already, what I'm calling a summary description of what we're trying to accomplish. And I will show you that in a moment. But in the handbook, there is a more extensive description, including a bunch of extra things to do and a bunch of extra things not to do. So I'll take a quick look at the handbook and point you to things that you should read. But let's go through these slides first. So essentially, we're calling this the Precision Landing Challenge. And this photograph actually is of a high power rocket with a precision landing parachute system on it. And so if you want to watch an actual hour-long lecture about this is actually fairly recent. Click on that link and go check it out. But that shows what it could look like. In other words, a rocket descending under an asymmetrical parachute, which has some control ability so that you can make it fly north or fly in circles or fly in some way. So part of our precision landing challenge is make your rocket land somewhere specific, quite possibly not where it would normally land. So we can distinguish the people who got lucky from the people who actually did accomplish what they set out to do. Another part of the precision landing challenge, which is not part of that particular lecture, is making the rocket land vertically. And so there are points associated with the two halves of this challenge, and you can pursue both halves or you can pursue only one. I'm not totally sure in my own mind which of those will be harder. This is hosted by the Minnesota Space Grant, represented by me, and by the Tripoli Minnesota High Power Rocketry Club, represented by Gary Strike. And we will repeat this information at another VideoCon, so you don't have to log into that one, but you can send other people if you want to. That'll be first thing in January for the teams that are planning to spend most of their time working on this later in the year as opposed to in the fall. Okay, so we already did introductions. We did round robin introductions. Here's how to reach Gary. Here's how to reach me. My recommendation in general is if you have a question, if it's logistical in nature, it comes to me, but you should copy Gary. And if it's technical in nature, it goes to Gary, but you should copy me. Sometimes I have opinions and he always has opinions about things. That's great. So you can get 2 for 1. Write to both of us, please. Here's a little bit of information about last year. So last year we had 13 teams registered. We were kind of coming out of COVID. We're still sort of coming out of COVID. And of those 13, 10 of them actually made it to the fly-off, which was in Minnesota in May. The other 3 made some progress, but for one reason or another had to withdraw. This year, we're hoping that we can possibly get more teams involved in that. And I appreciate all of you being on this call as preliminary evidence that there is some interest in what we're up to for our precision landing challenge. Here's what you need to know about. There is a handbook. It's posted and will be reposted probably later tonight. Consider that, I'm not saying tentative, but if we decide that I missed something, because I mostly did the edits and Gary hasn't had a chance to weigh in on them, we'll just post another version. So always go to the website to look for the most recent version. We'll talk about the cost of being involved in this, the schedule, parameters, some things that you need to do before the competition and some things associated with the competition itself. Competition is in May. Some comments about safety and judging, and happy to take questions even as we go, but we'll definitely stop before 8 o'clock and take Q&A. So this is what the front page of the competition handbook looks like, and here's a direct link to that website. So basically this thing has the competition dates. So maybe this is important. The competition has moved forward by 1 week from the date that we had chosen last year and the date we had historically chosen. In fact, we have essentially occupied what is going to be the Tripoli, Minnesota public launch weekend. And so this is going to complicate things a bit for the club, but they are willing to move it forward in part because both Gary and myself were having issues with doing it on the supposedly normal weekend. So watch for that. I realize that's close to the end of the year, possibly before, possibly just after the end of the year at different schools. But make sure you can have people who can show up on those dates if you want to be involved. For the moment, our registration fee remains at $400. It has been that for a long time. And basically, we will take $100 of the $400 and allow you to spend it on motors purchased from Gary. And in fact, the bare minimum motors that you'll need for this competition cost $100, literally. You might want to spend more than that. And if you do test flights, and you're supposed to, then you will end up paying more than $100 for motors. But we'll apply $100 of your fee towards motors, and then we'll use $300 of your fee to do other things, like pay for the venue and things like that. We will loan out, as we have done in the past, a data logger. So we'd like everybody to have some standard data logger. An altimeter 2 is what we plan to use if you happen to own one, or an altimeter 3, which is the same device but talks to your phone. You're welcome to use that instead and not borrow from us. And this also states that this is a data logger. Despite the name altimeter, it doesn't actually fire ejection charges. So you will also need a real commercial altimeter to fire ejection charges. And the plan is to do 2 flights. One will be the low flight, the first flight on a specific H-class motor. So it's the H225 White Thunder motor from Cicerone. That's a 38 millimeter diameter motor. I point that out because the second flight is required to be on a motor that's not 38 millimeter diameter. So you need to have a rocket that can compensate for having 38 millimeter diameter motors and 54 millimeter diameter motors. We'd like all teams to get used to how to do that. The first flight needs to go at least 1,000 feet up. That shouldn't be hard. The second flight cannot exceed 3,000 feet, but needs to get as close as possible. And so those details are the one page that's missing from the handbook right now, is exactly how to calculate the number of points based on exactly how close you got to 3,000 feet. Still thinking about that. I'm just about done. So if you end up paying more than $100 or wanting more than $100 worth of motors, I suspect you will. You'll have to make up the difference and pay Gary, because he's the person who provides motors for our launch site at our competition. On the other hand, if you actually fly from a field elsewhere, there presumably is a vendor who serves that field, and that's where you would probably want to purchase your motors from. Space Grant, as a NASA program, I represent the Minnesota Space Grant. We need to keep tabs on how many people we interact with. And so we require you to be in touch with your state's space grant. We call this sponsorship, but it doesn't actually obligate them to help you in any way. But you need to report to them that you're doing this, and hopefully they will help you, okay? So here's a list of costs, approximate costs: registration fees, building rockets, certification flights, I'll talk about that in a moment, and paying for motors and etc. Okay, so if they are willing to give you some money, you could come forward with a list of estimated costs. And here are some nominal beginning numbers without any numbers for travel. And the reason is travel from far away and travel from not too far away differ dramatically, so I didn't even bother putting travel numbers in here. But be in touch with your state's space grant. And then for any state that provides a lot of teams, we'll actually ask them to also provide help provide judges for the competition. So here is the summary description that we've already posted, and this has been out for a few weeks now. We want you to use a steerable parachute as opposed to some sort of thrusting device, as opposed to a wing device. A steerable parachute, okay, in a totally unpowered descent to guide the rocket booster, just the bottom section of the rocket now, back to land as close as possible to a specified target. We'll tell you where the target is going to be the day before flight. So we're not announcing it now. The reason we're not announcing it now is because it might change depending on the weather. If the winds are from the north, we might choose a specific location. If the winds are from the south, we might choose a different location. But we will choose a location and let you know approximately 24 hours in advance, in which case you can then report to the judges the night before you do the flights what you're going to do, how you're going to reach that target. So expect there to be a target and be ready for it, and then we'll tell you the target, and you can report on your approach to getting your rocket booster to land there. I keep saying booster because the lower section of the rocket that carries the motor is the only section that we're actually working with in this competition. Normally, we expect the rocket to come down entirely tied together, the upper section tied to the lower section. In this competition, we're allowing people to have the upper section fall separately, but if you do that, it has to come down safely under its own parachute. So you can separate things and only work with the booster, or you can leave the rocket fully tied together, but all of the points will be related to what happens to the booster, where it lands, and can you get the booster to land upright. So the second part, part B, is to land the booster so it remains upright for at least 30 seconds, preferably forever. One of the things that we're not going to allow is just to put big spikes on the booster so it just spikes itself into the ground. That would be slightly too easy and frankly slightly too dangerous, okay? Because there might be people down there too. So our expectation is the booster lands without penetrating the ground. And you might say, well, wait a minute, my parachute's going to immediately topple it. That's actually quite likely. So you are allowed to release the parachute, perhaps just as you're landing, in hopes that the booster stays upright, even if the parachute drifts away. As long as you can get the parachute back, you have to recover everything. As long as you get the parachute back, that might be a reasonable approach. You'll fly first on this H-225 motor, and then later fly to a higher altitude, but not to exceed 3,000 feet above ground level. We also want every team to add some sensor suite to their rocket. Okay, so this sensor suite is supposed to do minimally GPS, pressure, acceleration in 3 axes, and rotation about 3 axes. Okay, you can do more than that if you want. The device to control the parachute, assuming that you have an autonomous device, you might want to radio control the parachute or try to autonomously control the parachute. But if you're trying to autonomously control the parachute, then presumably having GPS information available to you on board will be useful. We'll also give teams bonus points for increasing their certification level. So there's details about this, not so much in the slides, but in the handbook. But I'll just give you the rundown right now. Basically, for every level 1 certification you get between when you sign up, and so I'd say sign up right away so you can actually start qualifying for these points right away. Between when you submit a notice of intent with your name on it and the competition date, every level 1 certification will be 2% added points, 2% bonus. Every level 2 certification will be 4%, but you don't get the 2% on the way to the 4%. So in some sense, it's 2% for level 1 and another 2% for level 2. You can think about it that way if you want. If you already have a level 1, you can go straight to level 2 and get 4% right off the bat. Level 3 is 6%, although I'll tell you right now, level 3 is probably not worth. It's way more than way more expense and way more complexity than level 2. So my expectation is most teams who pursue these bonus points will do some level 1s, maybe some level 2s, and you're capped at 10%. So frankly, you can't have 20 people all get level 1s and come up, just completely run the numbers. Okay, so no more than 10% bonus total, but you'll be able to do it by getting level 1, level 2, or even level 3 certifications for team members. And interestingly enough, since those rockets have to be individually built and are technically unrelated to the competition rocket, you can even bring a previous rocket as long as it was individually built. So some people who built a level 1 rocket last year could technically return with that same rocket, not build a new rocket, and fly it for level 2 certification, assuming the rocket that they built is up to a level 2 motor. Some rockets are, some rockets probably not. Okay, so that's the summary description, and then there is more detail in the handbook. Here's just a picture of what it might look like. Oh, one more thing I didn't mention, and that is that we expect on the booster section of your rocket, you have what I'm calling up-down camera footage. In other words, something that looks vertically up the rocket and something that looks vertically down the rocket. That might be a single camera, it might be 2 cameras. One way or another, we want you to have footage that shows the parachutes above and what's going on below. So the up-looking camera will capture, hopefully, the parachute and what it's doing. The down-looking camera might capture your landing. And if you deployed landing legs or something, it should be able to see that. And it's the down-looking camera that will give evidence to the judge that you did stay upright for 30 seconds. If, for instance, you approach the rocket and it's fallen over. It's like, well, maybe it landed upright. Let's look at the footage. Okay. So you'll need up-down camera. And so on this little picture, it says launch, boost, collect data, and up-down video. And then you need to pull a parachute, at least one, at apogee. You might choose to do dual deploy or not. And then on the way down, you want to attempt to steer the device as well as video, of course, and then you attempt to land the booster section, at least upright, and also continue collecting video. Other things that are listed here, just mention the fact that you have to have a non-commercial sensor suite. By non-commercial, it just means something that wasn't sold specifically for rocketry, something you put together with an Arduino or a Teensy or some microcontroller. And then sensors. You don't invent the sensors, you buy the sensors. You need to put this device together and make sure it can stand a rocket flight. I already mentioned the fact that you'll fly on 2 different motors with essentially 2 different altitude, not targets so much, but one is an altitude minimum. You want to go higher than 1,000 feet. You want to do that anyway, because if you're really low, you won't have enough time to actually steer the thing to a target, especially one that's maybe up to 1,000 feet away. And then the second one, which shouldn't go any higher than 3,000 feet, but will use a significantly more powerful motor. If you're doing certification flights, you might have to do some certification flights on the day of, or possibly before the competition. So you do a level 1 certification in March, and then you come to the competition in May and do your level 2 certification, which requires taking a written test. All parts must be recovered. Make sure that you get all the parachutes that are coming out at least by 500 feet. Below 500 feet, you might fiddle with things, I suppose, but by 500 feet down, we want the thing to be ready to land safely, even if everything else doesn't actually work out. Okay? A chute release means holding a parachute closed and then releasing it at some altitude. Those are allowed. Just don't come screaming down under a chute release until 100 feet and then try and open it up. We need things to be open so you're in a safe mode by 500 feet. And then anything that you open below 500 feet is gravy, is bonus, okay? Make sure you get everything back. So have people ready to run after stuff that's windy and the stuff is blowing away. We do recommend that you put tracking devices, especially if you're going to separate the rocket and you have the nose cone falling independently with its own parachute, that's fine, but that thing might drift a long ways away because you're not trying to steer it. You better put a tracker on that just to make sure you know where to go and get it, especially on the second flight, which could easily fly out of sight. You won't even see where that thing lands. So think about that. Make sure that ejection charges are fired by commercial altimeters. You can develop your own altimeters, but don't count on them, please. And we will lend you a altimeter 2. And you need static margin between 1 and 5. You need a thrust, weight to thrust ratio. I guess it's not on the slide, but at least a 3. And you need to have things landing no faster than 35 feet per second. Frank, you may think that that should have been 25 feet per second, but EEE actually changed that rule. Did you know that, Frank?
Yeah, I saw it and I don't really care for it. I always shoot for 15 because I like to make a soft landing, but yeah,
No. You're completely on target. You don't want to fall at 35 feet per second. It is allowed, and so we're going to go with it in the rules, but definitely you want to land appropriately, and 35 feet per second is not necessarily the right landing, especially if you're trying to keep something upright and not break off the legs.
Right.
Thank you. Okay, continuing on here. We want you to tell us what you're planning to do before you do it, so that we, especially Gary, can try to steer people at least a little bit. We call this our draft of design, and the expectation is that before you build something, if you're building a kit where someone else has sort of thought through it and work, right? You can go ahead and do that, but you should report to Gary that you're doing so. But everything that you're doing from scratch, and frankly, your main rocket will be a custom rocket for this competition. Pretty much has to be. You can't buy a kit that does what we're asking you to do, as far as I know. Get that to Gary before you build it. And so no later than the 10th of February, and frankly, if you want to build in the fall, that's fine. Just get him a draft of design, what you're planning to build, before you start to build it, even in the fall, and he'll get back to you with some comments. So the draft of design will talk about the major functional components. It'll talk about what your simulations suggest of how it should perform and how tough the things are, what things are made of, what their weights are, and stuff like that. So that's due no later than the 10th of February, but that's not really a due date. That's due before you decide you're going to build. And if you decide you're going to build earlier, then that's due way earlier. Another pre-competition in this context just means before we meet in May, okay? We want every team to show us that they can build and fly successfully a rocket, a model rocket probably, okay? So unless all your team members already have high power experience, which might be true, but if it's not true, we want you to at least go through the motions of building and flying a model rocket. And you should report on the fact that you've done that when you turn in another report on the 10th of March. I would suggest go ahead and do that next weekend. No point in really waiting on this thing. Unless you're still getting team members together, you might want to wait till your team is complete before you do this so that everybody can experience this. You can request a waiver from this if you have an entire team with experience. Here's an example. I'm currently teaching a class on high power rocketry. By the time I'm done, those students will all have high power experience. If they decide to form a team and join this competition, I won't force that, but I might allow it. That would be an example of a team that all has high power experience and therefore might be able to get a waiver from this requirement. Don't worry though, it's easy to go out and build and fly a model rocket. So if you don't get a waiver, no big deal, just do it. It's a valuable thing. One last thing for pre-competition, and that is we want you to do some outreach. Speak to at least 10 people at some point about what you're up to, okay? And then let us and your Space Grant know, and that's because Space Grant likes to keep track of the outreach that gets done in their state by people along these lines. So that will be due with another report, which is due on the 1st of May. And so make sure that you get that done. Don't forget to do some outreach, but you might want to wait until perhaps March or April when you actually have a rocket, and then you can show the rocket at the outreach, rather than doing outreach now about what rocketry might be like later on. But you can choose. You can do stuff now, but I would sort of recommend you do it later. Here are the aspects that are judged for the competition. There are 3 written reports. One is the preliminary design report that's due in March. What are you going to do? And you might have already started doing it. This is not the draft of design. Draft of design is due even earlier, and it's not considered a written report for judges. It's just a notification to Gary, frankly. And then there's the flight readiness report, which is due about 2 weeks before the actual competition. And this tells what you have done and how it has performed already in flight, because you're supposed to test fly it. There will be an oral presentation at the competition. We will do the flights and you'll get judged on those as well, but neither of those is a written report. But then after the competition is over, there will be one more written report. How did things go? That will be due approximately 2 weeks after the competition is over. And the following slides just talk a little bit about what's in it. So the preliminary design report more or less says, what are you up to and what are the designs? And so you have to do a fair amount of work before you generate this report. And you really should do this work before you start building things, because this is the designed work. But this is not actually due until March 10th. I would suggest you don't wait until March 10th to actually do the things that are mentioned in this report. 25 pages max. And then you build your rocket. And once you build and test fly your rocket, then you have your flight readiness report, which talks about how well this rocket did. And if it didn't do so well the first time you flew it, what are you going to do about that? Okay. So this one is due at the beginning of May, and it has essentially analysis of actual flight results. So if you don't get a flight in, I hope you do, but if you don't get a flight in because you're running behind or the weather's not cooperating, you will lose points. That doesn't mean you can't come to the competition, but that means you won't score particularly well on this report. If you have some certification flights, you should mention that as well. The fact that you have done or not done some certifications. There's the oral presentation. In some fairly fundamental sense, this is just an oral version of the flight readiness report, telling people instead of writing down. The nice thing is the judges will have read your written reports. You don't even have to start from zero. You can just dive right in, okay, and give them more details. This will be 10 minutes per team plus some Q&A time, and we'll do all of these the day before the flight. So this will be done on a Saturday, probably afternoon into the evening, and then the flights will be on a Sunday, weather permitting. And it's likely that these oral presentations will be done somewhere here in the Twin Cities. Historically, we've done these in North Branch, and I think we're not going to do that next year, as in next May. We'll probably meet in North Branch on Sunday evening for a post-flight banquet. Not North Branch, actually, just south of North Branch, Wyoming, Minnesota. But probably we will do our presentations the day before, not close to the launch field, but rather close to where many of the teams are from, where I'm from, and that's the Twin Cities. And then there's the competition flight itself. This is worth 20%. And in the handbook, there will be a rubric, more or less, showing how much points you get for flying safely, for flying appropriately timed. You'll have an hour, more or less, to prepare a rocket and get it flown. And then how many points you get for being close or not close to the target, and for landing upright or not. Landing upright or not, that's almost all or nothing. It's like, hey, it landed upright or it didn't land upright. There might be some judge's discretion there, but put all together, this will become 20% of your overall score. And then the final report, more or less, how did it go? So approximately 2 weeks after the competitions are over, we'll ask you to give us a shorter than the other 2 reports, a shorter report just talking about, well, what happened, and in particular, if it didn't do what you expected it to do you understand why, and what ideas do you have to do about that? There will be safety reviews. You will have a mentor, and if you don't have a mentor, you need to talk to Gary, and he can help find you one. A mentor is a certified person who is not a student, who's not on your team. It could be a faculty member if your faculty members are certified. But anyway, so the mentors will be watching what you do and giving you feedback and performing essentially all these informal safety reviews. But then when you come to the competition, the team, the club that is organizing the flights, will do 2 safety reviews, one the day you arrive and one just before you fly. and give you feedback. And if they don't like what you're doing, they'll try to give you ideas of how to fix it. But if they say it doesn't fly, it doesn't fly. We're not going to contest that. So you need to make sure that what you're doing is safe so that you can pass muster when it comes to safety reviews. The judges will be reading the written reports, and then they will also be listening to the oral presentations and probably be present at the competition and helping observe the flights. We might have some other observers for flights as well. And depending on how many teams there are from your state, for instance, if Wisconsin ends up sending several teams, often they do, we'll ask somebody to judge from Wisconsin, and it may well be Frank, for instance. Minnesota usually will have a bunch of teams, and so we might have more than one judge provided by Minnesota, whether they're from Minnesota or not. So I've mentioned all these dates already, but here's a summary. Basically, we want you to file a notice of intent. This is non-binding, but let us know right away that you're planning to be involved. List the people who are going to be involved if you know them. If you're still recruiting people, get back to us with an updated copy when you can. Draft a design before you start to build. Here's a new thing, and that is the timelines for getting motors has extended even beyond 6 weeks, which is what it was about a year ago. And so now it's up to about 3 months. So basically, Gary is telling us he needs to know by mid-February what you need in mid-May for the competition. And he needs to know well before mid-February, like January, what you need for flights in April or even in March. So once you have a design in mind, you'll know what motors you need. And I would suggest you contact Gary right away if he's the person providing you with the motors. Let him know, so that you can get the motors in a timely manner. And then the end of January is really when you put your money down for sure, but you may have to order motors before that, frankly. And February 10th is when you last possible date to get in your drafted design. And at that point, we'll even ask you to start telling us who's going to be showing up in May. By March 10th, we want your first written report. And hopefully you have a lot of work behind you, even when you produce this report. Test flights, perhaps in March, perhaps in April. By the 1st of May, the test flights should be behind you, so you can be reporting on them. And then we're getting together on the 13th and 14th of May. The 15th of May is the backup weather delay date. And then by the end of May, we should have final reports submitted in early June, competition results announced. Okay, that was very quick. I do want to show you one other thing, though, and that is the handbook. Okay, so the handbook, what I would consider the most important part of the handbook. Oh, here is something, Gary. This might or might not happen. I might want you to try and fix the table of content. But,
sure, I can do that. Yep.
Okay, but here's the deal. Right on the very beginning of the handbook, it states that same paragraph. This is our summary challenge. But as soon as you finish the summary challenge, it goes, oh, by the way, here are some additional details. And the additional details go for a while, okay? Okay, and so you really should read these additional details. And if you have questions about them, this includes you, Gary, let me know, okay? And so for instance, here are things you should not do. You should not have multiple motors. You should not have multiple stages. You should not have air starts. You should not have canards. You should not have gimbal nozzles. Don't worry, there's plenty of things you should do, but here's a bunch of things we don't want you to go. Just kind of heads up, don't go there, okay? So no ground penetrating landing mechanisms. All those javelin or harpoon landers, things that just stick in the ground when they land. They're just too easy and too dangerous. So we're not going to let you go there. We need you to land something that will naturally stay upright without digging itself into the ground. Okay, and then here is the description of the bonus points. So 2% for every level 1, 4% for every level 2, but you can't have any one student claim any more than one of these. So if somebody gets a level 1 and then the same student gets a level 2, they get the level 2 percentage and they don't get the level 1 percentage. Somebody else has to get the level 1 percentage. And there's 10% maximum across all categories here. Of course, the main rocket, the competition rocket itself, is built by a team, and so it can't serve as a certification rocket. That's the main thing I want you to see in here. Basically, if you go on down, it gives more details about the rating rubrics and stuff like that for the different reports. So spend some time with it. And there's one page, and it's noted in here, that's missing. That's the page that explains how we're going to assign points based on how close you will be. And I'll tell you right now, if you can get within 50 feet of the target might be 800 or maybe 1,000 feet away. If you can land 50 feet, within 50 feet of the target, I would consider that pretty much bullseye. We'll give you full points for distance. But if it's 100, not 50, slightly less. If it's 200, not 100, slightly less. If it's 400, not 200, slightly less. If it's 800, not 400, slightly less. And if it's more than 800 feet from the target, we'll more or less say you didn't manage to steer toward the target. Okay. And then one flight is 1,000 feet or a little bit more, and one flight is 3,000 feet or a little bit less. But these distances are the same. Still want you to nail that same target at the same distances, and it might even be easier to do so from the higher flight because you have more descent time in which to do your steering. But you'll have a low flight, you'll have a high flight. In both cases, you'll try to aim for a specific target, which might be about 1,000 feet or so away from the launch location. You need to know the GPS location that you launched from, the GPS location that you landed, and then you can calculate the distance. We're not going to step it out. We want you just to calculate it based on GPS values and then report. Yeah, you landed 250 feet away, and therefore we get this number of points. I think I'm going to stop so that I can take questions. Before I take questions, though, Gary.
Yes.
Add sort of advice to teams?
I'm sorry, what?
Any advice you would like to add besides what I just suggested as far as rules or things to watch out for, things that you've noticed have given us trouble in the past?
I think we've already touched on this with respect to motors, but in general, they're particularly in the electronics industry, there are significant supply chain issues as yet. So from a procurement perspective, you want to try to order what you need as soon as possible. So once you understand, if you need a specific altimeter, you try to find it. There are some devices like the altimeter 3s, for example, that we used to use, have not been available for well over a year now. And they just, I don't know when they're going to be coming available again. So you just make sure that you go through and try to figure out what you're going to use from that perspective and get those ordered right away. Yeah, and then same thing with the motors. The manufacturers are giving me 3-month lead times, and so that's why we have a 3-month lead time for you guys. So you don't want to be late with those motor orders. You want to get them in as soon as you can. And then any particular questions? You also said this, James. Let James and I know what they are, and we will answer any technical questions you might have.
Super, and hope for good weather. Frankly,
Right.
Basically, this happens to us every year, and that is, the last or maybe the second and the last, flight opportunity get canceled because of the weather. And so you don't want to count on, it's like, yeah, we're going to be building and we'll just do it on that day and we have no recourse. Also, if you fly something and it doesn't perform well, and especially if you break something, it's like, well, that'll take a little while to fix. And the later you do the flight, less time you have to do the fix. So we encourage people to think about a schedule and have that schedule not go up to the very last minute. Just give yourself some buffer, some safety margin, shall we say, or some extra time in this particular case. Frank, you've been doing this for a long time. What do you think we should be telling teams, especially ones who might be new to this sort of activity?
If you're shopping around for electronics, as Gary was saying, you're going to find some available on Amazon or somewhere else. Be aware how old that is, and also past teams that you're going to borrow altimeters from. Kind of find out where they were stored. Like if they weren't stored in the dash window of that person's car, or or if it was laying in the field and it's wet. Don't trust that altimeter. Try and get a reputable vendor or manufacturer that the altimeter is pretty much new, and that's a safe way to go. If you have doubts, always test. Just do a little vacuum tube jar and suck the air out of it and see how it operates. That's the safest way to go.
That's a good idea. Or you could maybe even imagine putting an altimeter onto a model rocket flight where it's not needed, but at least it will go through a rocket experience and tell you and log data and tell you whether or not it could have done the right thing.
Right. And also some of the LEGO batteries might have been sitting around in the in the flight boxes of other students, or the dash or the back window of a vehicle. Always check those out if they're always sustainable, and they're cheap anyways. Buy new ones.
Okay, so thank you for words of wisdom from both of you. Other people with questions, people with
James, there's if you look in the chat, there's a question for you too.
I have not been watching the chat, but thank you for telling me to do so. One moment. Okay, so I'm running up to the top. What do Frank and Gary think of the idea of harpooning?
Oh, we answered that one. Well,
So
the
I
last
did
one.
answer. Okay, so I'm ahead of you, Steve. Okay, so I'll tell you a funny story. One of our competitions a few years ago was that you had to have the rocket separate in flight, and you got points for how much higher the top of it went than the one. So one of my team members told me, we're just going to lash that bottom section to the ground, and it will run up the end of its cable, and then it will stop. And I said, that's a very interesting idea. I suspect safety will not let that one pass. Okay, so Gary said he thought that would be disallowed, and that we've already gone that way. So will you conduct weekly meetings to introduce rocketry as you did last year? Fine question. The answer is no. I'm not offering rocketry lessons. I sometimes offer online lessons. I'm not doing that. On the other hand, the recordings from last year still exist. And if anybody is interested in using recordings of me talking about rockets, let me know and I can point you to those recordings. Other comments, other questions? I have a question for Caden. No, I don't. I was going to ask Caden if he would be willing to serve as a mentor, as an advisor or whatever to a team. But frankly, we don't want our judges to be mentors. So frankly, Gary will be a mentor and I will be a mentor, but neither of us will serve as judges. Caden wants to be a judge, which is great. So I'm not going to ask the question. I wouldn't mind getting a few other people back, like Max Jetzer maybe, or Chris Gosh or whatever, to see if we could get some people as helping as mentors to teams if teams need mentors.
James, I have a question.
Go ahead.
Not having read the rule book, obviously, and we're landing the bottom section of the rocket. I'm not trying to bend the rules, and I'm just trying to think what could happen. Could a fin can be built for the 38 millimeter and the fin can be built for the 54 and still be attached to the bottom part of the rocket, as opposed to making a converter or
okay, so I think what you're asking is, are you allowed to swap out your whole fin can instead of just swapping out the interior of your motor mount tube?
Right. Could a team do that?
Okay, so number one, that's a Gary question. And number two, I don't think that there is any need for that. This is just my opinion.
Right.
It's easy to adapt to a different size. On the other hand, sort of the more genuine question is, are you allowed to swap out your rocket so it looks like this for one flight and it looks like that for the other flight? And I think the answer is going to be no. We want it to look the same. On the other hand, you might put ballast in on one flight, or you might put a bigger parachute in on the other flight, or something like that on the inside. But I think we don't want fundamental changes like this one has a longer body section, or this one has a different shaped nose cone, or this one has 3 fins and that one has 4 fins. I thought where you were going was, can I just have a really, really, really wide fin can, like a fin can that's 4 feet across, because then when it comes down, it's probably not going to tip over. And I suppose the answer is you could, as long as you could get it off the rail safely, but that also might, Gary might have an opinion about that.
Yeah, I think we said it's we're flying the same rocket, right? With the H-220, 255, whatever it was, 225, and then to 1,000 feet, and then 3,000 feet with the 54 millimeter J. So if you're switching the fin can out, I don't know that it would really be considered the same rocket. So I think the real option there is what the intention was, is to get people used to using adapters.
But I mean, we want people to think outside the box, but we also want to ask our opinion about things. And so I think the answer is, don't swap out anything major on the rocket, but you will have to put an adapter into the motor mount tube, and people should learn how to do that. It's really not hard.
Yeah, and you could make your own. You don't have to necessarily buy one, right? So.
All right, Flan, I got my microphone fixed.
Ahead,
So yeah, either whatever you guys need help with, I could be a mentor or a judge. And I'm sure Max would be willing to help as well, or Adrian also flies out of Tripoli, Wisconsin as well. And I don't know if you know Adrian, but Chris is actually on campus. He's getting his master's right now, so he might be a little bit busy to do something like that. But
is Max still involved in working at the physics department at Madison?
I don't believe so.
No, he's working.
Does anybody know where Max Stetzer is right now?
Yeah, he was at Bong yesterday.
Yeah, he's working. I forget which company he's working for in Madison. So he's still working in Madison, but I don't think the physics department.
Right, and him and Adrian are like this when they come to the launches. So they're pretty good. They're good mentors. They always bring people with them that they're mentoring anyways.
That's great. Okay, so here's another question from Steve. What kind of Velcro sticks to grass? I like your thinking process here, Steve. You're welcome to use something that sticks to grass as long as it doesn't penetrate, but I don't know if Velcro sticks to grass, but I bet you could find out just by getting yourself some Velcro and going outside.
I know what sticks to grass: weeds.
You can fly your rocket with weeds attached to it, and then it will definitely stick wherever it comes down.
Yeah.
Other questions? Okay, well, we're just under our 8 o'clock time limit, so maybe I will call it good. But if you have more questions, by all means, get in touch. Spread the word that documents are out there, and we're interested in talking to people and encouraging people to sign up for this competition. And I look forward to hearing from your teams if you decide to pursue it. I hope you do.
All right, good job there, James. It looks like a good competition. Hope we get a lot of teams.
Okay, thanks, Frank. Good night, everybody.
Good night, everyone. Thank you.
Thank you.